Good afternoon. So my name is Ian, and I'm going to be talking a little bit about the Eclipse platform and mainly focusing on the UI development section of it. So today's agenda will just have a brief introduction about myself and why I'm merely qualified to be here, what the Eclipse Foundation is, a bit about the SWT, so Simple Widget Toolkit and GDK, and understanding SWT, and with snippets and also an application called Control Example. Next, we'll also get into how to get started with Eclipse development. So I'll go through some kind of first steps if you are interested in doing something like that. Some general debugging tips that I've come across and have come from experience and learned from that. And my experience with developing Eclipse and its own community. And lastly, just some closing remarks. So I'm a fourth-year computer science student at Simon Fraser University in the beautiful city of Vancouver, British Columbia. That is not Vancouver, that's actually New York, so it doesn't have any correlation. So I've been a software engineering intern at RedHat since May 2016, so it's about 6 months now. And I've been working on the Eclipse, with the Eclipse Foundation since. So some of the open source contributions I've done, as explained earlier, I've done some HoverZoom Chrome extensions, a chat IRC bot, and a CDOT local complaint notifier for one of the hackathons I did a couple years back, which is a web application. So my main objective today is kind of give you guys an insight of what the Eclipse Foundation is and then how it relates to the Eclipse platform and provide developers an easier approach in getting involved with the open source development of Eclipse. So we're going to talk a little bit about the Eclipse Foundation. Just a quick disclaimer, I may say some errors simply because I'm just a student like some of you guys are, and please don't hold me accountable if I do say something wrong, but let me know if you guys know something that's right and I'm saying it wrong, please let me know. So the Eclipse Foundation. So basically it's a community of individuals and organizations wishing to collaborate in a commercially friendly open source software. So the Eclipse platform, which you guys may have known as the Eclipse IDE, originated from IBM in 2001 and was later kind of built from that and maintained by the Eclipse Foundation. So from a recent study I've looked at, it's still the most widely used IDE for Java development. And the best part about the Eclipse Foundation is it promotes open source software and promotes freedom. So here is a tiny graph I found that kind of describes what I just said earlier. So the IDEs used most often. This was done 2 years ago, so I don't think there's been that huge of an influx of change. Eclipse has been one of the most widely used ones for Java development exclusively. And then you have trailing ones like IntelliJ and NetBeans, and et cetera. So the Eclipse platform itself, as the IDE, is composed of mainly 5 large components. And it's Platform UI, SWT, RelEng, Debug, and Resources. So I'll kind of go through a little bit of each one for you. So in terms of Eclipse, it tries to be very modular. And that's why it's kind of split up into these 5 sections. And you'll continuously see that within the Eclipse development kind of just overall development of things. People want to be very modular about it. So for example, we'll talk about RelEng. RelEng is basically release engineering. So that deals with build cycles and basically the release engineering. So going from source to download. Debug is handling the debug system of Eclipse. Resources is kind of the very, very main model of how Eclipse works. So projects handling, file handling, etc. And lastly, what I'm mainly going to be talking about would be SWT Platform UI. So these two are kind of the things that I've touched upon and mainly been working on for these past 6 months. So next, we'll start with Standard Widget Toolkit. So the Standard Widget Toolkit is a graphical widget toolkit with the Java platform. So it's written in Java. It was originally developed by IBM as well, but it's currently retained by RedHat, IBM, the community, and other kind of others as well. So what this is that the main goal for SWT was to create a widget library that is native to the operating system. So as you can see in the screenshots, this kind of tries to express it. I know they're kind of outdated because they're older versions of things, but bear with me. It kind of still gives the same concept. As you can see, this kind of quick app that was made in SWT, in Mac OS X, it kind of relates to how Mac OS X looks like when in terms of how the widgets look. So you can see that it differs with Linux and Windows Vista. And what it does is basically it grabs the native widgets from the operating system instead of creating its own. So such things like alternatives besides SWT being like Swing. Swing kind of composes of more customizable widgets, and it gives more like a same kind of feeling of widgets across all platforms, whereas SWT kind of focuses more about the operating system level of things and trying to keep it similar to how the operating system wants it to look. So if you guys are aware of toolkits, it's pretty similar to how AWT works, which is Java's, but it extends that. So it's offered more additional widgets like tree and table. So next, I'm going to talk a little bit about GDK. GDK itself is another library, but this was written in C, and it's developed and maintained by the GNOME project. Now, the difference is that GDK has realistically no affiliation with Eclipse Foundation, but SWT bases most of its widget library with GDK. So the primary target for GDK is at the windowing systems based on X11 and Wayland. So this would all be like GNU Linux operating systems. So you can see kind of the divide here, because with SWT, we're trying to maintain a native widget across multiple platforms like Windows, Mac OS X, Linux, whereas GDK's main focus is Linux. It uses GDK as an underlying library for graphics representation. So on the right, this is kind of just like a very, very general app. I think it's the GNOME calculator. So it may kind of give you that Linuxy feel of how Widget Toolkit looks. So how does SWT communicate with GDK, and why does it do that in the first place? So let's talk about the very, very top. So platform UI is the very basis of the UI of an app. So in this scenario, we're going to talk about Eclipse. So Eclipse actually uses SWT as a library. So let's assume that platform UI is Eclipse. Now, what Eclipse does, it talks to the SWT library in order to get its widgets and provide the application. Next, what SWT does is it talks to a file called OS.java. Now, what OS.java does is that because SWT is written in Java, it needs to be able to communicate with GDK, which is written in C. So there needs to be some kind of cross communication between the two libraries and in two programming languages. So with there, we have static calls that are called to GDK that are more important. And also, we also have a header file called os.h, which is important because there are dynamic calls as well that we need to handle. Next, there is an environmental variable called SWT_GDK3. And that will either set with the 1 or 0, depending on if you want to use the GDK2 or GDK3 libraries. And either way, using GDK2 or 3, it's going to use the GDK backend library. So on the right, if you guys aren't too familiar with how widgets and widget toolkits work, this is a general hierarchy of things. And these two kind of diagrams are made by my colleague and friend Leo. He's very, very malicious with this, and he's very good and detailed about it. So in the right, we have the very, very highest being the widget. So everything below it inherits the widget. And as you go down, you start to see more familiar things that are related to widgets. For example, toolbars, trees, table items, etc. But it always bases off itself as a widget. So let's just go through a real-world example of kind of like snippets. And in my preference, I like to learn from snippets in order to kind of build my application from there. And if you're going to do any kind of Eclipse development, it's really, really important to understand how SWT works, so then you can start changing things within the UI as well, right? So here we have a quick snippet, and I'm just kind of going to go through line by line how it works. So in the very beginning, we have an instance called display. So this is important because what display does is responsible for handling communication between the user interface threads and other threads within the operating system. So this needs to be instantiated right away, and it only needs one per application. After that, we have a call called shell, and the shell's parameter is display. So what a shell is, easy enough to explain, it's just a window. So if any app pretty much has a window, and if you want a graphical user interface, kind of like a window, you're going to need to call a shell. So the shell is created, and then it uses the parent as display. Next, we're going to need to call a shell open, which is required in order for the window to even show up onto the monitor or onto the display. And something a little bit more interesting is this while loop here. So what this while loop does is that it checks to see if the shell or window is disposed, meaning if the shell even exists at the moment or is displayed or closed or anything like that. If it is not closed, it goes into this while loop. And within here, we have display.read and dispatch. So with display, within display, it handles user interface threads, like I said earlier. So with what read and dispatch as a method, it will check and see if there's any new events that are occurring within the operating system, and then throw it down into these SWT libraries for it to event handle. So once it does that and checks to see if there's any new events, and once it finishes all the events, it will leave the if loop and go into display sleep, which basically tells it to kind of lay off for a sec. And then it'll go back to the while loop and do this over and over again until all events are done. And even when they're done, it'll continue running it until the shell is closed. So once the shell is closed, so if you close the application, just a bit of cleanup the display, we'll call a method called dispose, and make sure anything tagged onto the display will be disposed properly. So I can just show you a quick example of that. I think that's snippet 1. Okay. So this is just a very, very simple app or application that just shows the shell. So what I described earlier. Are you guys seeing it? Yeah. Okay. So all it is just a shell window. It has nothing on it. Not very exciting at all. So let's see. Oh no. I'll just show it from here like this for now, because then I do have to switch back to my Eclipse here. So next we'll talk a little bit about a little bit more advanced usage of SWT. And in this way, we're going to run through the similar methods as before, but it's going to get a little bit more interesting. So in the beginning, we do have a display set up, just like I said earlier. And next we have a class called image. And where it will go is into display and into a method called getSystemImage. Within this method, we host a large amount of system images that you can call and use within the SWT library. And in this very scenario, we're just going to be using an icon question. Next, we're going to call the shell windows. And this is something new, so set layout. So with most widget toolkits, they offer some kind of layout system. So obviously, SWT is going to do the same as well. We have a few available. So we have grid layout, fill layout, row layout, and others as well. And in this very scenario, we're going to use grid layout. And what grid layout allows you to do is set the amount of columns and rows available. And basically from there, you're able to tell exactly which row and column you want to put your widget in. So it gives you a lot of ability to place your widgets where you want to put them. Without doing that, you also have the default grid layout, which is what's happening here. So there's no additional settings. It's just calling grid layout. So next, we have something called a button. So from within the SWT library, we have a widget called button. And we're going to create a new instance of it here, with the parent being shell. So as a second parameter, we have a thing called SWT.push. So what does that mean? Obviously, there's more than one type of button available in this kind of world. I mean, there's like radio buttons, push buttons, you name it, right? So with that second parameter, you're able to kind of choose which type of button you want to display. And in this very scenario, we're going to use a push button. So the next couple of lines are pretty intuitive. So you can use the button to set the image of the button, set the text, and also set the size of the window itself. In this very case, we're doing a 300 by 300 pixel size. And obviously at the very end, which is much preferred, is that after you set all these settings onto the window, then you open it as a final step. Once you open it, then we'll go into the while loop I described earlier, and some cleanup at the end. So I can just show you here. Great, so a little bit more interesting. So now we actually have a widget button here. So moving along from the same kind of snippet, I do want to introduce something a little bit more dynamic. So you're not going to want to make an app simply with just a button and that does nothing. You want to make it do something, right? And in this case, we're going to add a listener. So what listeners do is that it's going to continue listening for any kind of new events. And in this case, we have a button. We're using the button to add a listener. And one of the parameters is sw.selection. What this means is that it's going to check to see if this button was selected at any time. And once it is, the event will be sent to this function right over here. And from that function, we're going to run a little quick snippet of code. It can be a method, it can be open display, it can be anything really. So in this particular case, I'm just telling it to print hello. I won't demonstrate that, but it will just basically print this out. So next I'm going to show you guys control example. What I showed earlier were just very small snippets of code, and I do want to let you guys know within the SWT library we have a very, very useful tool for any developer that wants to work with SWT that kind of gives you a visual guide of how everything looks. Great. So within here, it's basically a collaborative effort to show all the available options, all available settings for every widget that's available in SWT. So we have a whole toolbar that displays everything. Just a quick tidbit, I built this over here during a couple weeks into my internship, and it just displays all the system colors that are available for SWT. Obviously, you wouldn't want to just call a random RGB value for some certain widgets, and you want to use something more static. So these are all the ones available in the GDK library as well as the SWT library here. So for example, you wanted a widget in this type of color, you'll know that this is the call you want to make instead of just doing the RGB values. We also, every tab kind of shows off a little different of a widget that is available, and these are all findable within the source code itself. Great. So if this piqued any of you guys' interest and you want to start doing Eclipse development, it's very easy. So one of the main things, obviously, is to download the Eclipse binaries, right? If you're going to do any kind of development, I highly recommend doing the development within Eclipse so then you can find new bugs, etc. So this website over here, or you can do a quick Google search of Eclipse, will let you download the new Eclipse binaries. So what I recommend as a developer is to not only download the most stable build, but also try to push and download the nightly builds. The reason being is that currently Eclipse is at Neon, and we are going forward with pushing into Eclipse Oxygen. So being Oxygen, we have all the newest patch updates, all the newest features, and within that, it's better to use that and play with that to develop Eclipse than to use a more stable version. So once you've got yourself an Eclipse copy, you got to register yourself as a Eclipse member. So you just go to the Eclipse website, and there is a create account on the right. And from here, you can create yourself a new account. So once that is created, you're able to log in and take a look into all the bugs available. And once you've created the account, you have to sign an ECA, which is the Eclipse commit, or at least Eclipse contribution agreement, which basically says every one of your commits are going to be open and available and transparent. So next, I'm going to talk a little bit about Eclipse Bugzilla. So this is where you kind of can get most of the jobs done and seeing what is available for you to work on. SWT and Platform UI are just kind of small things that you can work on. As I described earlier, it's kind of split up into 5 different sections. So there's a lot of stuff available to you as a developer to work on if you're interested in working on such a large project. Here you can find new bugs. For example, you can do searches. There's a whole, you can do simple searches, advanced searches. It's the simple use of Bugzilla. And you can also file new bugs if you find anything related to Eclipse as well. So if you guys are interested in SWT development, so development of the widget library itself, my colleague Leo has written a beautiful guide that spans a very large amount. And here is some of the pictures I've used earlier. It really, really goes into depth of how SWT works and what you can do about it and how to realistically debug it and do everything with it and how it kind of ties in with Eclipse platform. And also helps you out giving you ideas and tips of how to do this more progressively and also optimally. So within that, we also have a thing called Platform UI. So Platform UI is kind of separate with SWT, being that Platform UI is how Eclipse communicates with SWT in order for the widgets to appear as an app. So this wouldn't be working on the SWT library per se. It's more about developing where certain things go in Eclipse and if any kind of graphical issues are happening within there. So this is also a really well-written guide from Eclipse to help you as a developer if you are interested in doing that as well. All these links are available to you. If you guys are interested, I can send you the PowerPoint. OK, so one thing about Eclipse development is that in the Eclipse Foundation, we do use a thing called Gerrit Review. I don't know if you guys have used it before, but I'll show you a kind of small demonstration of it. It's very powerful in the way that if there's any new commits to it, it's easy to view your code and review it. So let's take an example. OK, so within here, we have a small bug called regression progress view looks ugly, right? And perhaps you wanted to change this and kind of amend to it and fix the bug yourself. So once you got your ECA and gotten yourself an Eclipse membership, signed that, and got yourself an account, you can actually work on it. So consider that you're working on it now. And let's see. It doesn't matter. Say this will break, but if you save this and go into Git staging, and within here, you copy and paste your bug. So given some kind of commit message, and add your sign off and change ID. So as you can see here, the change ID is 0, and it's a default change ID. But once you commit it, it creates basically generates a unique one. So I haven't pushed this because this is an actual fix. But once it's pushed, it does something pretty cool. So I'm going to find you a bug report that basically has a push with a committed message already that shows how this works. Yeah, so after you've pushed it, it will show up over here as a Gerrit change. So within here, you see all the files that have been changed and also a log. So we use Hudson CI. So every kind of push you've done, we'll go through the Hudson CI and rebuild it to make sure if it's a success or a fail. Within that, any kind of committers can make comments to your change. And from there, you can make new patch changes, and it'll all be logged in this really nice display. So here are some of the mailing lists that you should be aware of if you're interested. SWT has one, Platform UI has one, GDK has one, and also anything kind of Eclipse related, we have just the main mailing list page. So if you're interested in working on anything else besides UI, it's available to you as well to kind of see what's going on within the new developments of Eclipse. So I'm just going to talk a little bit about debugging tips for the UI. One main thing that I've come across is that it's hard to kind of debug it if you don't know if it's an SWT or GDK related issue. So simply because SWT talks to GDK a lot, and if there is a bug within UI that happens within SWT, it might not be an SWT bug. It might be all the way back into the GDK realm. And if that's the case, we have to talk to GDK about it. So what I use is a thing called JHBuild. And JHBuild is a tool written by the GNOME Foundation, which is really nice because you're able to download and I'll show you the introduction. Basically, you're allowed to download the newest version of GDK that's available in master or any type of version of GDK. And from there, you're able to make a shell interactive mode. And from there, you can basically open any GNOME-related app or GDK-related app, which is SWT as well, and from that version. So you can really, really diagnose that and see which version of GDK is breaking or if it's GDK related at all. So also with environmental variables are useful. Like I said earlier, SWT under GDK, underscore GDK will help you decipher if it's a GDK 2 or 3 issue. And LD library path is also something similar to what JHBuild does. So you can tell it which library path for GDK is available. So if you already have precompiled GDK versions, you can set the library path to wherever the binaries are, and your application will run using that binary. And lastly, we have GDK backend. So this is useful for debugging any issues if it's whether it's an X11 issue or a Wayland issue. So next, you can also use the SWT automated tests. This is available within the SWT repository. So those are useful to see if there's any regression problems within your commit. And lastly, don't be scared to ask questions on Bugzilla or IRC. The community is very, very friendly, and everyone seems to help a lot. And even if you don't know, or if they don't know the answer, they tend to help you, kind of give you a good direction to where it's going, where you can find the answer. So the feature of SWT. Because we mainly use a lot of GDK stuff, we have to follow along with the release cycles. And our SWT developers don't really have any kind of influence within GDK mainly. So they have their own set of GNOME Foundation people, and we have our own Eclipse Foundation people. So whenever they release a new version of GDK, we have to make sure it's backwards compatible as well, and also works with their new features. That means any kind of deprecated methods, deprecated method calls within widgets have to be changed. Lastly, no, not lastly, there's also discontinuing custom widgets. So when GDK was created back in I think it was 1995, there was a lot of widgets that are not available within the GDK library. So one example would be tabs. And within that, so what happened with that is that SWT decided to create its own widget, and there are a lot of them. So those kind of are deprecated now because GDK has their own library which has those functionalities now. So one main thing is that we got to start merging custom widgets with GDK ported widgets instead. And one main issue is the C tab folder, which is the custom tab folder. They have a rendering engine that is separate from the Eclipse platform rendering engine, so we're trying to merge that together. Next, we're going to try to port Eclipse over to Wayland from X11. So if you guys are uncertain what the difference is that a lot of Linux distributions now are using, or most of them are using X11, and they've decided to maybe move on from X11 to Wayland. Fedora 25, the newest version of Fedora, will be adapting Wayland as its default. And what X11 is basically it's a display server architecture that was used way long ago, and it has a lot of outdated calls, meaning that, like for example, font rendering is done in the operating system for X11, whereas Wayland has decided, no, these are not really necessary anymore because most of this stuff should be done in the client side, as in the application side. So Wayland kind of simplifies it for our new app developers. So this is something that's going to be looking forward into the cutting edge technology. Like I said earlier, kind of removing deprecated methods out calls. And lastly, one thing that is pretty awesome is the multi-tab support. This one's kind of funny because it's one of these bugs that have been out there for a very long time. It has 88 votes. It's the most top-rated bug related to SWT and Eclipse. It spans from 2004, so it's been about almost 13 years now, and there hasn't been much progress. So one tidbit is that I have been actually working on this, so I just haven't touched it yet because I feel like there's a lot of people CC'd on this list. So if I do any changes to say I'm working on it, I don't want to alarm too many people yet before I kind of get a good working product. So what do I enjoy most about working on the Eclipse platform? Mainly, the changes affect a large population of users. So like I said earlier, there's a lot of people using Eclipse, and being able to kind of make changes to that and seeing people use it, and maybe even walking by and seeing someone use Eclipse and seeing my change there is really rewarding, and it's pretty awesome to be part of this kind of community. The community is super friendly. Everyone seems to be helping each other out. They're super supportive of the open source. And large projects are challenging because Eclipse is a very, very large code base, and there's so many parts to it that sometimes fixing new enhancements or fixing new bugs takes a lot of time and effort because you have to relearn everything and start kind of like in the very beginnings of how this bug even came out. And there's a lot of stuff behind it and a lot of back-end stuff. So it could take a lot of time, but I think it's very rewarding in the end because I've had times where I fixed really old bugs that span from 5-6 years, and no one seems to want to fix it or want to do it because it's a lot of research to do. And once it's done, I get comments from all around the world sometimes on Bugzilla just thanking me. And it's an awesome kind of feeling to know that someone out there has appreciated what I've done. So cutting edge development UI, this is kind of relates to what Wayland is. like we also have to be made sure, like especially working in Linux, there's a lot of new stuff that's happening with UI. So we have to make sure that we support that. And lastly, kind of getting experience with advanced Java concepts. So as a student, a lot of projects that I've been working on previously to this haven't been very advanced. We do kind of our own calls, and they're very small snippets of code. So once you kind of get into the industry and see a lot of people working on larger scale open source projects, you see a lot of uses of concepts that are kind of, you kind of hear about it in school, but you never actually get to use it. And being able to kind of work in this large project and seeing it used and getting experience with it is really valuable. So that ends my talk, and are there any questions? Cool, no, that's it. Thank you.